So now we are going to move to our second law, which is the law of refraction. So this is now law of refraction, and we know that if we have two mediums, so one is has a refractive index n1, this one has a refractive index n2. Let's say this is air, this is water. An ray of light is going to come and meet at the interface. So this is going to be alpha, our angle of incidence, and then it's going to get bent a bit, and this beta is our angle of refraction. So as per the Snell's law, always valid, n1 sine of alpha is going to be n2 sine beta. We have proved that using Huygens principle this and observed it through experiments. As we know that we are going to deal with a lot of signs here in our exercise, so we need to clarify some of the behavior of sine function here. Sine function we'll look into slightly more detail so that we understand Snell's law comfortably. So sine theta. Sine theta is nothing but it values is basically if we have a right angle triangle. Let's do this one. Okay, so this is A, B, C. This is the right angle. This angle is theta. Sine theta is nothing but the ratio of AB perpendicular divided by hypotenuse A by C. So we just need to measure the length AB and divide it by AC. So what will be the value of sine 0? So imagine this is becoming 0, which means that AB is equal to 0 and we divide it by AC. So sine 0 is going to be 0. So here again, as this angle theta increases in this direction, the value of sine will increase from 0 all the way to 90 degrees, where it will become sine 90 is going to be equal to 1, because this AB will be very big and AC will be equally big, and they will overlap to form sine 90 is equal to 1. So between 0 degrees to 90 degrees, and as we know 180 degrees is called pi, so other way 90 degrees is called pi by 2. So between 0 and pi by 2, basically the value of sine theta is going to increase like this between 0 and 1. Okay, so sine theta is going to increase and take values between 0 and 1 from 0 to 90 degree. We can see that in the table here. So we have, this is 0 degree, and this is pi by 2, which is 180 by 2, or is equal to 90 degrees. This is pi by 4, this is 45 degrees. This is 0, this is pi by 6, so 180 divided by 6 is 30 degrees. It's pi by 3, so 180 divided by 3 is 60 degrees. So we know the value of sine theta, sine 0 is 0, and sine 30 is 1 by 2, sine 45 is root 2 by 2, and sine 60 is root 3 by 2, and sine pi by 2 or 90 degree is basically is equal to 1. So we just have to remember this because we'll be using sine theta quite frequently when we are going to deal with a lot of reflection using Snell's law. So And also you can refer to the value between 90 degrees and 180 degrees using this table in the future whenever you need it. So this is from 90 degrees to 180 degrees. So it actually decreases so this is our 0, this is 90 degrees, and then the value starts decreasing and again becomes 0 at 180 degrees. So with this background, we can start dealing with a lot of refraction using simple Snell's law. So to recap, basically we are going to do is basically, let's say we have a interface. So this is medium 1. It has a refractive index n1. This is medium 2. Has a refractive index n2. And let's say n2 is greater than n1. So it is a denser medium. So whenever the n2 is greater than n1, it means that n2 is a denser medium. Okay. So we can say that probably this is air and this is water. Water is denser than air and it has certain value n1. So now we have a ray of light which is going to meet this interface. So this is a straight line, sorry, the bad point, but this is a ray of light. It's coming like this, it's meeting the interface over here, and we want to know what will happen to it. So first thing first, we need to draw the normal to the surface at 90 degree. And now this one is going to be our angle of incidence alpha. And now this ray of light will go in certain direction, and this one is going to be beta. And we can find that beta by simply plugging in n1 sine alpha. We know this alpha is equal to n2 sine beta, right? Now, as we said that n2 is greater than n1. So, for this equality or the Snell's law to hold, what it means is that the beta has to be smaller than alpha, right? Because the value of this is constant, and if this one is greater than this one, then this sine beta has to be smaller than sine alpha between the range 0 and 90, because between 0 and 90 the value of sine is always increasing, right? So what it means, the beta has to be less than alpha. It means that in this scenario, basically we have this interface. As we said, we have this normal, and now we have a ray of light coming like this, and we said this is our angle of incidence alpha. And now we want to know the beta. First, we know that the light was not disturbed or refracted, it will proceed in this direction, right? But we know that the light gets refracted, so it is going to go something like this. And this angle from the normal is our beta. And as we said, if n2 is greater than n1, the beta will be smaller than alpha, which means that the light will actually bend towards the normal, right? If it is not bending, this one is alpha, right? The beta has to be smaller than alpha, so the light will actually bend towards the normal. So we can see that happening here. So light ray coming like this, sorry, light ray coming like this will not go straight and bend towards the normal if n2 is greater than n1, which means that whenever a light ray is actually entering a medium, so this is interface, this is a denser medium, this is a lighter medium, So whenever the light ray is entering, it is going to bend towards the normal in the denser medium. And other way around, the light ray denser. So this is light ray is coming from the denser medium. Don't expect so it will not go like this, but it will bend away from the medium, like away from the normal, like this, right? Because if we have to satisfy, so this is our alpha, this is our beta, this is n1, let's say n2, and we are saying here the n1 is greater than n2, right? So this is a denser medium and this is a lighter medium. So in that case, for the we'll write the Snell's law very simply. N1 sine of alpha will be equal to n2 sine of beta, right? We know that n1 is greater than n2, right? So the alpha has to be smaller than beta, which means the beta has to be bigger than alpha. So the light ray cannot go like this, but always bend away from the normal. So here is our concept. When a ray of light travels from lighter to denser medium, it will bend towards the normal. Secondly, when ray of light travels from denser to lighter medium, it will bend away from the normal. So this is a simple concept developed based on Snell's law, and we need to remember this.